Okay, welcome to Surds video number 2, and today we're going to do expanding brackets with surds. So we're going to do normal brackets, and we're going to do double brackets, single brackets and double brackets, and we're going to kind of look at all the kind of eventualities that you might have to see. So here we go, here's our first example, root 2 brackets 5 plus 3 root 2. Okay, so this is just an expanding bracket. Do not overcomplicate it. Just because it has got surds doesn't make it any different. And like I said in the last video, if you think about your surds as being like x's, that will make it easier. So this is like x times 5, x times 3x, and that will make it easier for you. So we're going to expand it as normal. So we've got root 2 times 5. Well, that is just x times 5, which is 5x. So root 2 times 5 is just 5 lots of root 2, 5 root 2. Then we've got root 2 times 3 root 2. If you want to write this out separately, each bit, so that you understand what's going on, that is absolutely fine. Now, in the last video, we did multiplication, and we talked about how we would do this. So I said, do your numbers first. So the number in front of your surds first, obviously this is a 1, 1 times 3 is just 3. And then do your surds. Root 2 times root 2 is just 2. So the answer is just 6. So the answer to this question is 5 root 2 plus 6. Okay, let's look at another one. Let's say we had 7 root 5, open brackets 3 root 2 plus 4 root 5. Something like this. Okay, we cannot simplify inside the bracket at the moment because the numbers underneath our surds are not the same. And as we learned earlier when we were adding, in order to add surds together, the number underneath the surd has to be the same. Just like if you had x's and y's, 3x plus 4y, you cannot simplify that further. Okay, so we're doing 7 root 5 times 3 root 2. Do your numbers first. 7 times 3 is 21. Root 5 times root 2 is root 10. So it's 21 root 10. Again, we've got 7 root 5 times 4 root 5. Numbers first. 7 times 4 is 28. Root 5 times root 5 is 5. Okay, so then we become 21 root 10 plus 28 times 5, I'm hoping, is 140. Let's check. Yes, it is 140. Can we simplify that any further? No, that is as simple as it goes. The only way you could simplify that further is if you could simplify this root. Now, root 10, if I try to simplify root 10, I don't know that it's root 5 times root 2. Now, can I simplify that any further? Nope. All it goes to is root 10. So that is as simple as it goes. Okay, right, let's do some double bracket. Let's do one more actually. Let's do a slightly more complex one. Something like root 8, 5 root 2 plus, let's think of a good one. Don't mind me, I'm just thinking of a question. Let's go for that. Okie dokie. So, up to you how you start this. You might think, oh, root 8, root 50, they're quite big. I could probably simplify those. You could simplify them straight away if you would like to. Okay. I think instinctively you probably won't do that, and so I'm not going to do that for now. Okay, but you can do, there's more than one way to do this. So, we've got root 8, and we are timesing it by 5 root 2. Do your numbers first. So 1 times 5 is 5. Root 8 times root 2 is root 16. Tell me about root 16. What is the square root of 16? Oh, it's 4. So that bit is just 5 times 4, which is 20. Okay, then we have got root 8 times root 50. Now, those are quite nice numbers. If you had to do some really horrible numbers and you couldn't do the multiplication, it's in non-calculator, you might want to rethink and you might think, maybe I should simplify first. And if you want to do that, that is fine. Anyway, we'll end up with root 400. Root 400 is the same as, hopefully we all know, 20. The square root of 400 is 20. So my answer becomes 20 plus 20, which makes 40. Now, these will appear in a non-calculator paper, but obviously we are not in our exam at the moment, so we can check our answers, can we see, using our calculator. So I'm literally going to type in the question, this question here. Alright, I just want you to be able to see the calculator, which you can't very easily. I'll put it back in the light in a second. So root 8 times 5 root 2 plus root 50. Okay, and hopefully when we click equals, unless I'm a terrible teacher, it's going to come up to 40. Way! Happy days, it did. Okay, right, so that's expanding normal single brackets. Let's now go on to expanding double brackets. Here we go. Example 1 of double brackets. Double. And obviously it works the same for triple brackets if you ever have to do a triple bracket, okay? Here we go. So 4 plus root 5 and 3 minus 2 root 5. We haven't had many minuses, so we'll put some minuses in. Now, I don't mind how you expand these. They are a pair of double brackets, so you might use foil, you might use the banana, or you might use a grid. Now, in my opinion, students get on better when they use the grid because then they don't mess it up. But it's up to you. You can do whatever you like. Okay, so I'm going to do this in a grid. 3 times 4 is 12. 3 times root 5 is 3 root 5 plus. 4 times minus 2 root 5, 4 times minus 2x is minus 8x, which is root 5. And this last one, you need to be careful. So minus 2 times 1 is minus 2. Root 5 times root 5 is 5. So the answer there is minus 10. So my answer, 12 plus 3 root 5 minus 8 root 5, take away 10. 12 take away 10 is 2. 3 root 5 take away 8 root 5 is minus 5 root 5. That is your answer. Again, pop it into a calculator. It will simplify to that. Okay, and so then the worst style of one you will get is something like, here we go. I keep using the same numbers, which is a bit annoying, but we'll roll with it. Here we go. Something like this, although I haven't put any minuses in, but there we go. Okay, now you might look at these numbers, particularly this one, and think, blimey, that's a big number, let's simplify first. It's totally up to you how you do it. Now, I am going to simplify first because otherwise I'm going to have to end up doing 8 times 72, and I just don't fancy doing that, okay? So I'm going to take root 8, and I'm going to do my factor tree on it, okay? If you don't spot it straight away, it is fine, you can simplify it later. That is root 2 times root 2 times root 2. We learned how to do this in the first video. So that is 2 root 2. Let's look at root 72. Again, root 2, root 36, root 2, root 18, root 2, root 9, root 3, root 3. So that is root 2 times root 2 times root 2 times root 3 times root 3, which is, they're a pair, and we've got root 2 in the middle. So that is 6 root 2. Oh, I don't know why I put a bracket on it. Okay, so that means that our sum, our brackets, become, they were already 5 root 3, so 5 root 3 plus root 8, which was 2 root 2, times root 72, which is 6 root 2, plus 4 root 3. Okay, now again, I don't mind how you do this, but I'm going to do it in a grid to see if that will help you. Okay, I'm going all over the place on my paper. So, off we trot. There's 5 root 3, there's 2 root 2, 6 root 2, and 4 root 3. Off we go. Right, brains in. 6 times 5 is 30. Root 2 times root 3 is root 6. That can't simplify anymore because that is as simple as that goes. Okay, 6 times 2 is 12. Root 2 times root 2 is 2, so that makes 24. 4 times 5 is 20. Root 3 times root 3 is 3. That makes 60. 4 times 2 is 8. Root 3 times root 2 is root 6. Oh, that's as simple as that goes. I'm sure why I wrote it so small. And so we get 30 plus root 6 plus 24. What did I say? 30 plus root 6. I did not mean that. I meant 30 root 6 plus 24 plus 60 plus 8 root 6. And then we tidy. So 30 root 6 I don't know why I went so Somerset then, plus 8 root 6 is 38 root 6. 24 plus 60 is 84. And so the answer, 38 root 6 plus 84. Let's hope I did not make any mistakes. Tune in next for rationalising.